Hello, Jurie. On to our last talk of today.
Hello.
Hello. So, Jurie Horneman has been making games since 1991, starting with programming role-playing games in 68K assembly with the 16-bit demo scene Legends of Alien Software. He was the co-designer and main programmer of the cult CRPG Albion. Albion. You know, I've read that word a billion times and never tried to say it.
Albion, yeah.
Yeah, Albion. His area of expertise is the intersection of game design, AI, and storytelling, and he has spoken and written on procedural content generation, narrative design, and game AI. Most recently, he helped ship Watch Dogs Legion. He lives in Toronto, waiting for the dark mode fad to blow over, which is a wonderfully provocative statement.
Especially at this conference, I guess.
Yeah. All right, well, go ahead, Jurie.
All right. So, hello. My name is Jurie. When I pitched this, or when I thought of pitching it, I thought it was going to be technical talk. This is a production talk, so hope you find that interesting. So, I'm going to here to talk about dynamic content selection, which is when you select content from some pool or set at a runtime, as opposed to content that's sort of picked statically before the game runs. I need to stress that here I am not necessarily talking about procedural content generation the way you would see it in your typical roguelike. I'm not talking about like there's a seed and now you have a beautiful dungeon, right? I'm also talking about things like barks or Val style banter or storylets or what have you. So my thesis is that you need to approach dynamic content differently from static content. And there are two questions that I found useful to think about when working with dynamic content and dynamic content selection. And these questions aren't unique to dynamic content, but how you answer them is. Right? So this is the structure of the talk. I'm going to look at two examples from the perspective of two questions. Question one is, does it work? This is about functionality. Will your system even work at all? And you can sort of rephrase it as, can you prove your dynamic content won't break the game? And question two is about quality. Is this good? Does this dynamic content do what you want as a game developer under all circumstances? And this question is both easier and harder than the functionality question. It's easier because you can probably ship a game that has uneven quality here and there, but typically you can't ship a broken game. But it's harder because it's much trickier to define what good means. So to keep things simple, I made up my examples just for this talk, but they're based on real problems in real games that I've worked on. So let's talk about level generation using tags. So imagine you have this data structure, a level definition, and it's a simple grid. Each grid cell represents a room, and it has a bunch of tags in it. And imagine you have a bunch of tagged rooms. So this is going to sound like a joke. I apologize. Player walks into the room, and we see the tags ES Medieval Corridor. The game looks in its batch of rooms and picks a room and puts it in there, and there you go. Boom. There's a room. Player walks into the next room, SW Medieval Corridor. You'll probably have guessed that SW stands for where the exits are, so south and west, right? Game looks at its set of rooms, finds one, boom, there you go. And you keep doing that, and then you have a whole level. So what's nice about this, like level creation becomes really fast because to make a level, you fill a grid with some tags. So this kind of level creation is great for a low-budget live service game, and that is actually, where I worked with this approach. It's also great because it decouples level creation from room creation. You can have people cranking out levels and other people cranking out rooms with very little coordination. And so it's not like your typical level workflow where you have, a level designer who needs to coordinate with a level artist and they need to make sure they don't destroy each other's work and, they have to wait for each other. That all goes away. This is all decoupled. So, the dependency between the two is sort of, broken for production purposes. And the third point I want to make is like, this is not procedural level generation, right? So this is more like rendering a declarative level description, sort of a high level, like this is what I want the level to be like, and then the computer figures out the detail. So I could do a whole talk on decoupling in production. I could do a whole talk on declarative approach in game development, but it's not this talk, so I'm going to move on. So can we prove that level generation using tags won't break the game? I kind of discovered the hard way. You could definitely break the game with this approach, right? The player walks into a room with these tags and there's no room. So the game sort of goes like, it sort of crashes because what else can you do? There's a bunch of solutions for this. You can make some tags optional, as in try to find me a spooky corridor, but if you only have a normal corridor, like fine, I guess. You could add fallback placeholders to your room set, so gray boxed rooms for all exit combinations. Just remember not to ship with those, right? You can manually test every room. This is not procedural. We're not generating an infinite amount of levels. This is a very finite set of levels. You're going to be running through them anyway. You could manual test this, but you'd have to do it again and again every time anyone edits a level or room, right? And so the most powerful solution I found was to statically analyze the level data and the room list and to identify room requests without a matching room. So I wrote a little Python script that just loads those files and cross-references them and then outputs an error. And if you then hook that Python script into something like TeamCity or Jenkins, you can actually guarantee that bad data will never be checked in. So yes, we can prove that level generation using tags won't break the game. So what about the quality question? Now, you can't just play through levels and see if certain rooms appear too often if there's scarcity, right? And that's what we ended up doing, right? We did not have a lot of time or a big team, and we would be playing through those levels, all the time anyway. So I think that was okay. However, I do think some of that could have been automated to make it sort of easier to see where content is scarce and where players might keep seeing the same room. And I'll get back to that during the conclusion. So let's talk about a second example. Let's say you're making a fancy role-playing game. This is actually a screenshot from one of the role-playing games I did early in my career called Ember Moon. But you have a fancy role-play game. You have a big world. You have fights. You have classes. All the classical elements. And let's say you have a class like the Bard, who doesn't really shine in combat. So you want to give players who choose to play a Bard some cool Bardy thing they can do to avoid fights, right? So let's say that Bards can get a quest to avoid a fight, and something that involves charisma and songs and diplomacy and tall tales, rather than like swords and fireballs, right? And you don't want it to be the same quest each time, but you're going to have a lot more fights than you can make quests. So you make a pool of quests you can pick from based on the situation, right? Dynamic content selection. So you might have a quest that asks the player to get some ointment from a healer in a nearby cave, one where the player needs to go to a crime boss in a tavern to pay off someone's debts, and then a bunch more for whichever situation makes sense in this role-playing game. And then, because you have a big world, you need to adapt the quest to the current location. You can't have a quest that sends you to the same location every time, right? Because then the player is going to go like, oh no, there's an ogre, and the ogre quest, I know it's going to take me all the way across the world, and oh no, I hate that ogre, right? So instead, what you want to do, you want to dynamically pick nearby locations, probably based on tags, and use those for that quest. So when Bard players meet an unfriendly NPC, they get an extra dialogue option. And when they pick that option, the game selects a Bard quest based on whether they're trying to sweet talk an ogre or a goblin or whatever, and then adapts the locations based on where in the world the player currently is. And the quest itself does not change apart from that. So we have two kinds of dynamic content selection going on: one for the quest and one for the quest locations. So let's look at location picking for the functionality question. Can we prove dynamic location picking won't break the game? In other words, can we guarantee that quests will always get the location they need? And it doesn't matter if the player's seen those locations like 1,000 times and they're on the other side of the world, because those are quality issues and not functionality issues. So we'll get to that. Because if the quest goes like, hey, I need a tavern, and you're all out of taverns, all the other taverns of the world are taken by other quests, other systems, then your quest stops dead, and that's very bad. So can we use static data analysis here, like we did for the tag-based level generation example? And yes, we can. It's just that, in the real situation that this example is based on, this turned out to be significantly harder because this happened on a pretty big project. And, I'm just going to sort of go through some of the problems, some of the steps I had to go through and some of the problems I encountered. So first I needed to, deeply understand the system I was trying to analyze. And I had not written the location reservation system, location picking system, and then multiple person years of effort had sort of gone into that. So that was sort of step one. Then I needed to get the quest and the location data in a format that I could actually work with. And that can be non-trivial because many game engines and data pipelines are actually not set up for this kind of analysis. So I had to write C++ code to export internal data in CSV format, and then Python code to turn that into an Excel document. So then I had to deal with false negatives. So QA had actually found a few cases where there was an actual real life occurrence of this problem, right? So like, you start this quest, and then, boom, the game locks up. And I had sort of made it that if that happened, it would show like a really big dialog box that was even there in sort of non-debug builds, and really like, talk to Jurie, do not ignore this, to make it really obvious. So we had a couple of examples like that, and I had to make sure that the Excel file that I was working on would also say that this was a problem, right? Because if QA says like, hey, this breaks, and the Excel file says like, no, it's fine, then I have a false negative, and that's bad. And I also had to deal with false positives, right? So if the Excel file says, this combination will break the game, I sort of had to create a synthetic save game and verify that it would actually break the game, right? Just to so make sure I was doing my logic correctly. Then I had to work with content designers to come up with allocation rules and implement those in game. And I'll get to those in the next slides. And then I had to rerun that analysis regularly, whenever the data changed. And I had to, because I don't trust my own programming to the degree that I felt was necessary, right? I had to program a fallback so that even if it still did happen, there was, something. I actually forget what I did, but something to make sure that the player's save game isn't like broken forever, because that's sort of frowned upon. The pattern I found in the quests and the location were that there are quests that are like, give me any old building or street corner, it's fine. And then there are quests that are like, I need a tavern aligned with the Thieves Guild near the harbor in the city of, Dawn Tomb Fort or whatever it is. And so in other words, you have non-picky quests, and you have picky quests. The BART quests, from our example, being reusable and it's a bit more generic, right, are typically less picky than your core story quests, and that's kind of the point of those quests. And at the same time, your core story quest may need that one specific location, like, oh, we need the big confrontation, the big fight in the fortress or whatever, but they only need it once and then never again, because core story quests tend to, like, they're all about showing new things and moving the player forward through the world, and so they usually only need a location once. So one thing you could do is put your quest and your location to two pools, and places like that, that fortress, that you need for that one story quest, they can, they're in the story only pool, and then once that quest is done, that location moves to the general pool, and then the reusable quests like the BART quest can use them, right? And then suddenly you have, some owlbear healer, is in the fortress or something, whatever makes sense for your game. And that can help a little with solving the problem, because it ensures that these special locations are never taken, right? Like when that story quest comes along, it's it has a location it needs, so that's good. And it also makes more locations available later on to the reusable quests, so that sort of makes them, freshens them up over time, I guess is what I want to say. But that doesn't prove we'll always get a location. So I don't want to go too deep into the weeds of the actual allocation problem, and each game and each set of data is different. But in the end, I ended up with the following rule. If at a given point in the game, you know which quest can be active, and you have one quest that absolutely needs a green tavern, and 4 quests that are happy with any old location, all quests will work if you have at least 5 green taverns available, right? So I hope you can sort of like, infer like the kind of set manipulation I had to do, and the the things I had to do in Excel, right, and in Python to sort of present that data. But that is sort of what allowed me to prove that the game would never run out of locations, and as far as I know, it never did. So by the way, knowing which quests can be hard. Knowing which quests can be active at a given time is actually hard. What's harder is knowing the likelihood that all the quests that could be active are active, right? Like that, that is a really tough problem. And we just sort of assume the worst case, that like, the player that just grabs all the optional quests that they can, and it just like never closes them, and then keeps plowing through the game. But yeah. So yes, so you can prove that dynamically picking locations won't break the game. So what about the quality questions? Are the BART players having a good time? Remember we said that we want to dynamically pick a quest based on who the player is trying to avoid fighting, right? The BART player. So we have some quests that are good for dealing with owlbears, and some that are good for necromancers, some that are good for any opponent, right? And that probably uses like a tag-based system to define the constraints on each quest, because tags are the poor developer's constraint solver. But that means you can end up in a situation that I talked about with the level example, where the player gets a room, but it's always the same room, right? And in this example, your Bard player may keep getting the quest where they need to find an ointment for a common like owlbear complaint or something, right? And so the reason for that can be as simple as you having tagged that quest as being great for owlbears, and you just happen to be a place with a ton of owlbears. Apple Keynote does not come with owlbear shape, so I use squirrels. It's like, prove me wrong. It's good enough. All right. So, but what's happening here? You have two probability distributions, like how owlbears or squirrels, owlbears are spread out over space, and how your quest constraints are set up. And those distributions intersect to result in a high likelihood of one quest repeating. And that is much harder to analyze from data. And I'll talk a little bit about that towards the end. Now, let's look at the quality of location picking. And let's make our lives a little bit more interesting by adding some additional factors. We don't just want to pick a location that's is fitting for this quest. We also want to pick a location that the player hasn't seen in a while, and a location that is not too far away from where the player currently is, because that's the whole point where we're going through this, right? So we don't want to force the player to cross continents just to do a Bard thing. And let's assume that means that we have relative weights for both of those factors, right? Like recency and proximity, and some kind of weighting algorithm for picking locations. And I'll also get to that, the one technical slide. So anyway, the huge problem here is that proximity and recency are not things you can extract from static game data, right? They depend on where the player is and what they've done recently, and they are inherently dynamic factors only known at runtime. So you cannot use static data analysis here. Whereas you could still do that for the level generation by sort of calculating the scarcity of things, right? But this is a lot harder. And through some combination of how your world data and your quests are set up, it is possible your players get sent again and again to that one tavern in the harbor district. And maybe it's because it's the closest one, and you said proximity is slightly more important than recency. And there are perfectly good taverns at the other part of the city, but the weighting just you set it up that way, and it's not picking those, and that's that is extremely hard to debug. Now let me the sole technical slide here. Let me quickly go through sort of roughly how this algorithm and algorithms of this kind typically work, right? So you have a list of all your locations, right? We're talking about like a given quest, a given part of a quest, you need a location. You take all the locations, and then you calculate like a bunch of metrics or values, right? So here, in this made-up example, we have saliency, which is like how well suited is it for this particular quest, right? Like, and we're going to say like the prancing peacock, like the tavern, is better suited than the wizard's tower, right? For whatever reason. And then we have recency, and then we have distance. And then we take those numbers and we make it so that we can sort of smoosh them together into one number. That's the total score. And while we're doing that, we can do the weighting that I talked about, right? We can say like, hey, actually recency is more important than distance, or or saliency, or whatever it is. We can sort of do arbitrary math on these values. So you add it together, and then you typically you either pick like the location with the highest score, or you do something like you take something from the top 5. There's all kinds of variations. But basically, you pick based on that score. And because you have all those values, it is actually very cheap to sort of display those as a kind of debug tool, and it's pretty common. So either you print them all to the log, and you can see in a log like, oh, location request 23. Well, let's look at all these values. Or you make a little debug window, so you can go like, oh, why did why did this quest pick this particular thing, right? But what I'm saying is like that is not enough, because each individual selection can be fine, but it's over time that they add up to a bad experience, right? So what I think you need to do is log all of that data that goes into a content selection through your analytics system or some other system, and then analyze it over time. And maybe you can then spot problems and their root causes. And maybe you can even retroactively change the weighting and see like, would this have given me better selections, right? And I say maybe here because I have run into these problems, but I've never found a better solution than changing some weights and hoping the problem goes away, because we did not have this data over time, and we simply did not have the data to make a better decision than that. So those were the two examples. Conclusions. So this is what I said at the start. I hope I sort of convince you, right? Dynamic content selection, not that different. The two questions are the same. It's how you answer them that's different, right? If you add a rock to a level, you want to make sure that that didn't somehow break the game, which is rare, but we all have stories. And also, the rock made the level a little bit better, right? And that is such a common thing that we don't really think about it. Like, yeah, I'm going to play the game. I'm going to look at it in the 3D viewer or something. That's answering the two questions for adding a rock, right? But so my point is that answering those two questions is very different when you're doing something like tag-based level generation, or my other example. Static data validation is generally useful. I'm generally a big proponent of this, but particularly when independent assets need to work together, and that happens a lot with dynamic content selection, right? So levels need rooms, situation need quests, quests need locations, right? Those are all independent things that come together in a system, and especially when those bits come from different people, especially with different disciplines, right? Like in my example with someone making level definition, someone making rooms, is great. They don't need to coordinate to create their stuff, but the integration problem and the risk is higher there, and that's why it's particularly important to use static data validation. And I'm implying here, sorry, that this is automated static data validation, so you sort of have the computer do the work, and ideally have it done every time you submit data. So one thing that I sort of discovered while writing these slides, it wasn't really clear to me, but static analysis is data mining, right? And I'm not a data mining expert, right? But I know a little about it, and it's like, yeah, you somehow get the data, you massage the data until it has the shape you want. You analyze it, you form hypotheses, you confirm those, you make the whole process repeatable, right? So that takes time and effort, and like I said, you may need engine or toolchain support because your engine may not be able to give you that data that you really need. And another fun thing I discovered is sometimes you cannot start the analysis until your data is close to done. Like, we knew about the location problem early on in the project, but we also knew like we couldn't pick the right way to solve it because we didn't know how bad the problem would be, because we didn't have the whole world set up, and all the locations and all the quests, right? So we sort of had to keep waiting and go like, no, we're not going to answer this until beta, right? Which was sort of difficult in some ways. So you can answer the quality question by feel. You'll remember I said that effectively we ended up not automating or really supporting the quality question in the two examples I gave. We just sort of eyeballed it. It's effectively what we do for a whole lot of other content, but it is a risk and it could have gone wrong. So I feel like to do it right, you need something like analytics or a time-based logger system, and then analyze that data over time. And my final sort of like, what's the opposite of takeaway? Bring along is, when you use dynamic content, don't forget to budget time for figuring out if how you're going to answer these questions. It takes real work. It's a particular skill. Yeah. So I hope that's sort of if you take away one thing, it's that. So thanks. Roll the City Maps by Waterboo Procgen Arcana. Great projects from Itch. My employer's hiring. We shipped a roguelike this year, so wink, wink, who knows, and if you want to reach me, then you can reach me here.
Excellent. Thank you very much. That was a great talk. I'm very much looking forward to referencing it because I think, like your takeaway says, it is just so crucial to have that time to actually make the content good, and you need to take that time again if you change the content, which yeah, having also worked on these types of systems in big AAA contexts, and I'm sure it's also true in smaller teams, it can be difficult to get people to really understand why that extra time is necessary.
Yeah, and especially in this case, because I didn't know, like at the start of the project, like, oh, I'm going to have to do these things, right? It's more like something's on fire, let's fix it, right? So
Yeah, absolutely. And I think that point too, I really liked about knowing that the problem exists does not mean that you can solve it right away. Sometimes you have to wait until the data is there. I think that's a really great insight that, yeah, resonates with me.
Thanks.
Yeah, so we have time for a few questions. Please, people, go ahead and submit them or upvote them. We have one question here from Dash Clever. So with dynamic content selection, does it make sense to generate randomized player paths and choices to create test data? So that kind of, test player version. Is that something that you ever also used?
It definitely does. It's not something I did for the quality of the levels, but for that same game that the level generation example is based on, I kind of use that for progression balancing, right? So doing like tree analysis through a level and going like, well, if the player sees all the rooms, then they see, they hit so many enemies, and if they do only a few, then they do this, right? And then you can go into like, what is the probability distribution of those things, right? Um, yeah, definitely. And yeah.
Yeah. I'm curious, actually, in that case, like, did you ever go down further layers? Because you get, you talked about the relationship between locations and quests. Sometimes that keeps piling on of like, oh, okay, but quests have different quest rewards, and the different rewards feed into different type of progression. And so you get that version of like, oh, okay, well, now depending on which quests get generated, the rewards are going to be different, but then you're looking at the progression. And so
Yeah.
how do you start then balancing that, like, the quality and the like correctness of, is it possible to get in a situation where like there's no way to get owlbear feathers because it generates no owlbear related quests, and that's the only type of quest that has a reward?
Yeah. No, that's a great point, and it's actually in some ways maybe the even bigger takeaway. And I regret not putting this on a slide. Is it's very easy to design a system that sounds good and then is untunable or uncontrollable, right? Like certainly with progression. So these two examples were from two different games, and so in the level generation example, like the quests, we had quests, right? Or you had to go for these levels one by one, but that was pretty linear, and so there the non-linearity did not really harm, or like did not make it more difficult to balance sort of the progression. And the other game, like if you have a role-playing game and it's open world, the player can go anywhere at any time, right? And so it's very difficult to control that and to simulate that, right? And also, like I said, with the location picking, it's easy to make a system that is great and it's complicated, but then you need to answer that question, like, will this kill our game, like, and then that's sort of an additional use case that we hadn't thought of in the beginning, right? And you can end up with like I said, untunable or uncontrollable games if you're not careful.
Yeah, it's just you get into that almost like second order problem of rarely is a single piece of content just a single piece of content. Like a level has a bunch of stuff coming with it, a quest has a bunch of stuff coming with it. It gets more interesting the more layered that is.
Yeah.
But it gets harder and harder.
The data mining, well, it's like in the first question, right? Like generating random paths, through, yes, that's super cool. I'd love to do that. Do I have the time to do that, right? That's the other question. Like in the case of one game, we did not. Actually, in the case of both games, we did not. So yeah.
And I think it's good too. Like I appreciate talks like this because there are plenty of people who, especially in this type of group, are able to make games solo. In which case, the answer can be that it's all in your head. But often, if you have bigger ambitions, you end up working on bigger teams. Then you do have that. Like, well, QA needs to have certain things that they can check, and producers need to know things, and like your artists want to be able to work on assets without all being blocked by each other. And so it's cool to recognize tools for that.
Or you're a programmer and you really love to get some data from analytics, but there's like several departments involved in that, right? And they want to understand what these bytes are that you want to send across their network. That can be definitely.
Yeah. It's an interesting, provocative question, I would say, from Dash Clever. Would you ever design a system specifically to be easy to test first and interesting second?
I think if I would sort of, when you have, when you're designing a solution to a multidimensional problem, right? I can imagine myself finding like, oh, this is a neat thing. This is very easy to test, right? And then trying to make it interesting, right? As opposed to trying to solve both things at the same time, or going for interesting first and then hopefully going like, hey, can I actually can we ship this, right? Yeah, I don't know, like.
I think that's a good point. I guess it almost depends on your team, because I think there are some teams that would have high confidence that like we can take something that's uninteresting and make it interesting because we have that skill set. Like that is, I think, a lot of game designers would feel fairly comfortable with that. But then, do you have the technical capacity to take something that is interesting but untestable and build engineering tools to make it testable? Maybe you don't. Maybe then
I also wonder if we hear about the games that thought, that were not interesting and thought they would get there,
Yeah.
I mean, I guess some of them do ship, but yeah. I don't know.
Yeah.
It's a hard question.
Yeah. Interesting. Well, thank you so much. I mean, that takes us to the end of the time, but yeah, this is wonderful, and I think it's going to be a very referenceable talk, which is fantastic. So thank you so
Cool. Yeah,
much.
thanks for having me.